Hey everyone, welcome to the 5th chapter of the guidebook. First of all, before we even get going, let me just say way to go trying to connect with the content, trying to understand the key principles that are in the guidebook, and for growing your CAD and mechanical design skills. All right, the purpose of this video is to help you know what I think is most important for you to walk away with while you start to engage chapter 5 of the guidebook. Before I get to the main points, let me just say, the 5th chapter of the guidebook is the third and last part of the ET66 calculator. So it is in this chapter that you're going to finish up the calculator. You're going to get the aesthetics worked out, the colors of the buttons, the full assembly kind of going on there. You're going to make some engineering drawings and some renderings. All of this is in wrap-up of the ET66 calculator. I encourage you to keep going, do your best on this. You can end up with a great portfolio item at the end. Okay, there are 3 main things going on in this chapter that I want you to know about. The first one is that in this chapter, you will learn about creating engineering drawings. So we have to step back for a minute. In the previous chapter, we learned about assemblies. And in the chapter before that, we learned about part creation. So part creation, assemblies, and drawings are the 3 main things that we create in the CAD system. And you're learning this third part now, how to create engineering drawings. As you go about doing the engineering drawing, I recommend that you do 2 things that are particularly important. In this section, section 5.7, that's where engineering part drawings are described. And there are 2 kinds of standards that are described, industry standards and company standards for creating good drawings. You need to understand these standards and start to become familiar with them. And one way to do that is to look at section 5.7.1, which lists out the standards. And then in the figure that's on the following 2 pages, the figures show examples of those samples coming to play with the numbers on the drawings and the notes on the drawings. I recommend that you look at those and start to absorb them. When it comes time to making the engineering drawing, you'll make an engineering drawing for the battery door cover. And I just recommend, as strange as it sounds, to just try to copy the drawing that I created. And you want to do that conscientiously. You want to think about, why are the dimensions placed where they are? Why are the views the way they are? Why are the notes on the drawings? What is their purpose? And if you're doing that, I think you'll get exposed to the key standards for the engineering drawings. Okay, that's item number 1, is the engineering drawings. The next item is critically important, and that is the information about design tables. What is a design table? So first of all, whenever we make a CAD model, and the CAD models you've made so far, there is one sort of default configuration for that model that you created. But in the background of the CAD system, you can create alternative configurations. You might have, for example, like an ET66 button that's yellow or brown or green. Those are all different configurations. Or you might have a part like a screw, and one configuration is long and one configuration is short, and one configuration has a Phillips head and one configuration has a standard flat head. And you can create all those in design tables. How would that work? For a screw, for example, we would create a generic parametric screw, one of generic length, generic girth, generic threads, generic head type. And then in a design table, we could specify a number of parameters that would allow us to just basically click one button and get the new screw. Now, the key behind design tables is that design tables are executed, or I should say maybe created, in a spreadsheet-like format. And that spreadsheet-like format is what you're going to learn in this chapter, and you're going to practice it. I just need to pause for a second and reflect back on when I was a younger guy. I learned how to play the electric guitar. This is something I did for a lot of years. In fact, here's a picture of one of my bands that I was in. Okay. I was being taught how to play the guitar and how to be a musician from one of the very best guitar players in the San Francisco Bay Area named Steve Sage. And Steve Sage taught me something super important that's totally pertinent right now to learning how to play CAD. Play CAD, whatever. Do CAD. He said, if you can't play it slow, you can't play it fast. If you can't play it slow, you can't play it fast. So what does this mean? It means we have to figure out how to do the slow version before we do the fast version. And this is exactly what the deal is with design tables. You're going to find, here I'm going to scroll to the part that I want to be in the guidebook here. Hold on a second. Okay, section 5.2 speaks about design tables. And in particular, section 5.2.1 shows how to make design tables in SolidWorks. All right, I really recommend that you do everything you can to follow this tiny shaft example that's in figure 5.1. Try to absorb what's going on, and to help you with that, in the support videos, I have a bunch of information, a bunch of videos on how to create design tables, and I talk through this example. So don't let it skip by you. You're going to be in a much better position if you learn this simple example before you jump into the project of the next chapter, or before you attempt to do the exercises that are in this chapter. All right, that's second thing. And the third thing then is that you're going to learn additional CAD modeling skills that you didn't have before. Okay, so you're going to learn, for example, how to make threads, threaded parts. And by the way, there's a certain pattern going on in this chapter that is really worth paying attention to. And let's go back for a second to chapter 2, where we did the turbocharger gasket. In that chapter, there was a lot of me telling you exactly what buttons to push. And since that time, we've deviated from that, and we've taught sort of more principles, and you've had to figure out what buttons to push. In this chapter, we return just a little bit to me describing to you how you should do it, what buttons you should click and stuff like that. So, for example, in section 5.3, where you learn about threaded fasteners, there's a description about how fasteners are specified. For example, the fastener length, or the head height, the minor diameter, the major diameter, the thread pitch, these sorts of things. Those are described in that section. But right after that, in section 5.3.2, we have a description about how to add threads to parts in SolidWorks. So we're back to sort of pushing the buttons or knowing where to find the menu items. I really recommend that you look at those subsections in the chapter to understand how to do the stuff in SolidWorks. So another thing you're going to do, besides learning how to do threads, is you're going to learn how to change the appearance of parts. So the texture, the shininess, the color, and just as you can see in section 5.4, appearances are described, and in section 5.4.1, how to apply and edit appearances in SolidWorks is described. So we're back to sort of showing you how to do that specifically. All right, and then a few other things that are going on here. You're going to learn how to add decals and logos to parts. Okay, and again, section 5.5, decals, but you're going to see section 5.5.1, how to add decals to part files in SolidWorks. So pay attention to that. Also, same kind of things going on with rendering, which is the last sort of thing you'll learn in the chapter. Section 5.6.2, how to create renderings in SolidWorks. Okay, so where does that leave us? That leaves us with those three things that I think you should pay close attention to while you're doing the reading and preparing to do the exercises. The engineering drawings and the standards for the engineering drawings. That's item number 1. Item number 2 is the design tables. Don't let the design tables, in particular for this chapter, don't let the design tables slip past you, because it just means you can have extra work to do in the project to try to catch up on learning how to do the design table. And then the third thing is we have opportunity in this chapter to learn additional CAD operations that you didn't know before. Okay, the threading, the appearances, the decals, the renderings, and those sorts of things. Okay, that's it. I wish you the best as you work through this. Good luck.